So this is Leibnitz theorem. It's essentially used to find higher order derivatives, and it's a generalization of the product rule. So as a starter, I want everyone to find the third derivative of this function.
Just found the second.
Yeah, sorry, I just finished the second. It's already going on.
What do you get for the second?
I'm not reading it all.
It's E and then cubic.
So yeah, that will look like that.
It's 18.
It's 1800.
It's 36. It's 54.
Yeah.
Okay, 36 is 81.
What do you guys see for
E to the 3x multiplied by 27x cubed plus 81x squared plus 54x plus 6.
Okay, I disagree on the first two terms.
Well,
I like
E to the 3x multiplied by 27x cubed plus 81x squared plus 54x plus 6.
I messed up somewhere. I don't even know where I did the that's a good one. Oh, it's 9x cubed here. That's good.
Wow, if only there was such an easier method of finding higher derivatives.
I think this thing here you've got
If only there was an easier method of finding higher derivatives. God, this would be so much easier.
You guys got an answer?
We'll just copy them all out.
Is everyone finished? Yeah. Alright. Can someone just read out the answer for me?
27 x cubed e to the 3x
Factorize out the e to the 3x.
81 x squared e to the 3x plus 54x, you know, e to the 3x again. And then 6 e to the 3x.
Is that your final answer?
Yeah.
Okay, so I'm guessing most of you probably did the very long method, which is to 3 consecutive product rules. But as I said earlier, the Leibnitz theorem is a generalization of the product rule. So, as a general case, if we have a function y equals u times v, then how we know by the product rule, the first derivative of y with respect to x is equal to u prime v, keep the first, and differentiate the second one, and then you differentiate the v now this time and keep u. If we repeat the same logic for the second derivative of y, then you get the second derivative of u times v plus keep the first one, differentiate the second one, u prime v prime. Now the second function, differentiate v, you get v prime prime times u. Keep v prime, now differentiate you get u prime. So yeah, u prime prime v plus u prime v prime. And plus v prime u prime. Sorry, I messed up. So this one stays the same, and that one differentiates. Now here, this one differentiates, and this one stays the same. So these two are the same, so we can just add them together. Plus 2 u prime v prime plus v prime prime u. Now if you do the same for the third derivative, it's equal to u prime 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 v plus u prime prime v prime plus 2 u prime prime v prime plus 2 u prime v prime prime plus v prime 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 u plus v prime prime v prime. Now if you connect like times, then you'd see v prime prime v plus these two are the same, so that'll be 3 u prime prime v prime. Those two are the same. 3 u prime v prime prime plus v third derivative times u. And now if you look at the coefficients, then this might remind you of the Pascal's triangle. So essentially, if we have y as u times by v, then the nth derivative is equal to n choose 0 times by u to the nth derivative of u times by v plus n choose 1, which is just n, times by the n minus 1 derivative of u times by the first derivative of v plus n choose 2 u to the n minus 1 derivative of u times by the second derivative of v plus n choose n, which is 1, u times by v to the nth derivative. So that's the function there. So if we go back to our original question, we can solve this in a much easier way. Does anyone want to copy this down, or can I probably go off?
I think you always open another page if you want, and then it's the arrow that's like the plus next to the 1, 1 on the right hand side in the bottom.
Is it this
No, the one to the left of that.
This one?
Yeah, and then you can always come back, you can always cycle back to that.
So that's our original function. So if we let u equal to x cubed and v equal to e to the 3x, our first derivative of u is 3x squared. Second derivative of u is 6x. Third derivative of u is 6. And now v prime is just going to be 3e to the 3x. Second derivative of v is going to be equal to 9e to the 3x. The third derivative of v is going to be 27e to the 3x. Now if we apply our formula for Leibnitz theorem, then we know that the third derivative of this function is going to be equal to the first one differentiated 3 times, and keep the first one, the second function, plus 3 times by the first function differentiated 2 times, and the second function derivative of once. So applying our logic, we can say the third derivative of u times by v is going to be equal to 18x, 18e to the 3x.
6.
Oh, sorry. Six e to the 3x plus 3 times y. The second derivative of u is 6 times y. V prime, which is 3e to the 3x. So 18 times by 3 is 54. X e to the 3x plus 3 times by u prime times by v to the second prime is 27 times by 3, which is 54. Yeah.
27
Oh, no, sorry. Yeah, thanks. Plus 81 x squared e to the 3x, and u times by v prime prime is just 27 x cubed plus times by e to the 3x. That's our final answer.
I think it's brilliant. I'm literally very happy that I now know that, and also very annoyed with the hours that I've spent on Maclaurin series questions when I could have just done that. So better late than never. And very good for you guys to know that at this point. I just wonder what other maths tricks are out there that I just don't know about.